Assalamualaikum and good afternoon, guys. We continue our lesson today with a asynchronous lecture for the chapter number 1. So, we directly go to the slide of state and equilibrium. As we know, the thermodynamic will deal with the equilibrium state. So, what mean by equilibrium? Equilibrium is a state of balance. In an equilibrium state, there are no unbalanced potential or driving force within the system. So, if you have one state condition here, let's say the mass is 2 kg, the temperature is 20 degrees C, and the volume is 1.5 meter cube, it will cover all inside this boundary. So, for a thermal equilibrium, if the temperature is the same throughout the entire system, and for the mechanical equilibrium, if there is no change in pressure at any point of the system within the time, let's say, if here the pressure is 2 bar, it will equal inside this boundary, the pressure will be 2 bar. Next is a phase equilibrium. If the system involves two phases and when the mass of each phase reach an equilibrium level and stay there. Let's say you have partial of this volume is in, let's say we take an ice cube, and partial half of this is water. So this phase will go to the equilibrium of water if we let them at the room temperature. Next is a chemical equilibrium. If the chemical composition of a system does not change within the time, there is no chemical reaction occur. Let's say you have this volume, you put the natrium chloride chemical, the regular salt. So this regular salt will remain in all area of this volume. Okay. Next is the state postulate. The number of property required to fit the state of a system is given by the state postulate. The state of a simple compressible system is completely specified by two independent intensive property, meaning that is independent property. Simple compressible system mean if a system involves no electric, no magnetic, gravitational, motion and surface tension effect. This is, we call it simple compressible system. Next, we will go to the process and cycle. Process in thermodynamics mean any change that a system undergoes from one equilibrium state to another. Let's say this is state number 1. Okay, we have the dimension of in the y direction of property A, and for the x direction is property B. So from the state 1, it will move to state 2. So this is the process from state 1 to state 2, and the path or the route that the process go, we call it process path. So what mean by path? Path is the series of state through which a system passes during a process. To describe a process completely, one should specify by the initial state, the state 1, we call it initial state, and in this example, state 2 will be the final state, as well as the path is followed and the interaction with the surrounding. We also have the quasi-static or the quasi-equilibrium process. When a process proceeds in such a manner that a system remains infinitely close to an equilibrium state at all the time. Let's say we have a very slow compression. So at the initial state and the final state, we can say it a quasi-equilibrium. Next is the process diagram. we take a look at the PV diagram here. Okay, we have the initial state move to the final state of state number 2. The initial state is state number 1. We have a V1 here, and the final state or the state 2 is V2 here. So the process diagram plotted by the employing the thermodynamic property as coordinate are very useful in visualizing the process. Some common property that are used as a coordinate are temperature, pressure, and volume or specific volume. So from this diagram, okay, the piston cylinder device move or compress from the initial state of 1 to a final state of 2. So the system from this volume to the second volume here. Okay, so this is the physical, and we can plot it through this diagram. Okay, there are prefix of ISO. ISO is often used to designate the process for which a particular property remain constant. We will have in this subject, we call it isothermal process, a process during which the temperature is remain constant. We also have isobaric process, where a process during which the pressure P remain constant. And finally, we have the isometric or isochoric process, a process during which the specific volume V is remain constant. So what happened if the process from the initial state 1 move to the final state and back to initial state 1? This condition, we call it cycle. Cycle is a process during which the initial and the final state are identical. Okay. The steady flow process. The term steady implies no change with time. The opposite of state is unsteady or transient. We have a steady state, no change with time, and we will also have the unsteady or the transient state, where the temperature is is different. A large number of engineering devices operate for a long period of time under the same condition, and they are classified as a steady flow device. If the operation of the system in the long period of time, but same condition, meaning that the temperature is same, the pressure is same, so we call it steady flow device. Steady flow process is a process during which a fluid flow through a controlled volume steadily. The steady flow condition can be closely approximated by the device that are intended for continuous operation, such as turbine, pump, boiler, condenser, and heat exchanger, or a power plant or a refrigeration system. We will learn more this in the work, the third chapter, the energy transfer by work. During the steady flow process, fluid property within the control volume may change with the position but not with time. Okay, next is the temperature and the zero law of thermodynamics. So what is a zero law? The zero law means if two bodies are in the thermal equilibrium with a third body, they are also in the thermal equilibrium with each other. Let's say we have an iron with a temperature of 150 and the copper with a temperature of 20. In the isolate condition, it will balance, or it will reach the equilibrium thermal condition where the iron will go 60 and the copper will also go 60. This is an example of the equilibrium. By replacing the third body with a thermometer, the zero law can be restate back as two bodies are in the thermal equilibrium if both have the same temperature reading even if they are not in contact. Let's say they have a gap between an iron and copper with the boundary. It will also reach the equilibrium. The temperature scale. All temperature scales are based on some easily reproducible state, such as the freezing and boiling point of water. We take the ice point and a steam point. Ice point is a mixture of ice and water that is in equilibrium with air saturated with vapor at 1 atmosphere pressure. In zero, where it's 0 degrees C or 32 degrees of Fahrenheit. Steam point is a mixture of liquid water and water vapor with no air in the equilibrium at 1 atm pressure, meaning that it's 100 degrees C or 212 degrees of Fahrenheit. This is a ice point 0 degree and the steam point 100 degrees C. The Celsius scale is the scale of temperature in SI unit system. And the Fahrenheit scale is the temperature scale in English unit system. The thermodynamic temperature scale is a temperature scale that is independent of the property of any substance. It's independent. The Kelvin scale is a SI scale, and there's another scale, they call it Rankine scale. This is an English scale. A temperature scale nearly identical to a Kelvin scale, we call it ideal gas temperature scale. The temperature on this scale are measured using the constant volume gas thermometer. You will do the experimental in the laboratory of a temperature scale. There's one module on it. Okay, let's take a look on the PT diagram here. In the P versus T plot of the experimental data obtained from the constant volume gas thermometer using 4 different gases at the different but very low pressure. Okay. Either you use a gas A, B, C, or D. For the PT diagram, it will extrapolate to one point at